Hi, it's Mr. Anderson, and today I'm going to show you the diffusion demo of the Lab 1 diffusion and osmosis lab. And so first of all, to review, what is diffusion? Diffusion, remember, is the movement of molecules from an area of high concentration to low concentration. It's just due to molecular motion. So if we put some food coloring in water, the food coloring is just going to move apart. And that's because the molecules are moving. And so it's going to move apart until the concentration throughout is going to be the same. And so basically what you're going to try to answer after watching this diffusion demo is rank the following from smallest to largest. Starch, glucose, water, the pores in the dialysis tubing, and then finally IKI or Lugol's solution. So first of all, I should probably describe what all of these things are. Starch is going to be a polysaccharide, and so before we talk about what a polysaccharide is, we should talk about what a saccharide is, or a monosaccharide. Glucose is a monosaccharide. That means it's essentially C6H12O6, and so it is 6 carbons organized kind of in a hexagon. It's got a lot of oxygen and hydrogen around the outside, and so that's a monosaccharide. If we look at starch, so starch like that's found in a potato, starch is going to be a number of monosaccharides attached together. And so we call that a polysaccharide. And it's not just going to be a few like I'm drawing right here. A good starch or a good polysaccharide is going to have thousands of these glucose molecules attached together over and over and over. And so starch and glucose are both sugars, both carbohydrates. Now, it's just that starch happens to be a little bit bigger. Hopefully you're familiar with water. Water is going to be made up of two things. You're going to have one oxygen atom, and then you're going to have 2 hydrogen atoms attached on the side. And so water is simply H2O. Next one is the pores in the dialysis tubing. So we're going to put some liquid inside of dialysis tubing. We'll seal it off on either side. So it's going to be sealed off like that. But the pores in the dialysis tubing are going to be these microscopic holes that are in the dialysis tubing. Remember, dialysis tubing is used in kidney dialysis. And so you can't really even see the holes at all, but they're really, really tiny. And then the last thing is Lugol's solution, or IKI. The big thing that you're looking for here is going to be the iodine that's found in the Lugol's solution. The big thing that you need to know is that if you ever have Lugol's solution and starch in the same place at the same time, you're going to get a real blue color. So it turns to a blue color. In other words, if you were to take a potato and then just put Lugol's solution on it, you're going to get blue coloration on that potato. That's just due to a chemical reaction. But we use Lugol's solution, or IKI, as an indicator of starch, so where we're going to find starch. And so after you watch this demo, what you want to be able to do is rank the following: starch, glucose, water, pores in the dialysis tubing, and then finally IKI. You want to be able to rank all of those from the smallest to the biggest. Okay, so the video, since I'm at home, you can tell I don't have the chemistry equipment right here. And so I'm going to grab a video from YouTube. This one is I'm taking from Road to Utopia, and it's got quite a few hits, 32,000. It's been around for a while, but it just shows you a demonstration of this. And so thank you to Road to Utopia. You probably want to visit it to see the whole video. I'm just going to show you a portion of it. And if you go there, you'll also see a really good video of a dancing robot toy, which is worth the trip as well. And so thank you for that. But this is the diffusion experiment. So first of all, let me kind of get it started. So let's get it started. Okay, so let me stop it right there and draw on it a little bit. So what do we have in this experiment? We have in here a bag. This is that bag of dialysis tubing. And you can see that it's kind of a whitish, kind of a yellowish color. It's kind of sealed off on the sides. And so if we look at what's in there, inside here, we're going to have two things. We're going to put starch in it to begin with. Starch solution, and then we're also going to put glucose inside there. And then the other thing that we put, just to dissolve those, is going to be water. So we have those three things inside the dialysis tubing. Outside the dialysis tubing, so in this area out here, in the liquid portion of the beaker, we've got the, let me draw an arrow here. So out here, we've got water. And then we've also got the Lugol's solution. So we have this IKI. All right. The other thing you normally do before you start this is you start looking at the presence of glucose or the absence of glucose. And so you do that using these glucose test strips right over here. They're used to monitor glucose levels. So if you're a diabetic, it's a good way to see how much glucose there is in your urine is what we're looking at. Because if you have high glucose levels, it's an indicator of problems with regulating blood sugar. And so what you do is you put a strip into the fluid, and then it will change to a color. So it'll start as a blue color, but it can move all the way up to a red color. And this is what I use in class to figure out if there's glucose present. And so if we were to take this glucose strip and put it inside this, are we going to find glucose? The answer is yes. So we'll have a positive out here. And I just said over here a second ago that there's glucose in there, so that shouldn't be a surprise. If we were to take a test strip and look out here, we're going to find glucose out here. We'll have a negative for that. So there's no glucose out here to start with, but there's going to be glucose inside. And so this is what it looks like when it starts. So I'm going to have to get rid of this writing for a second, and then we'll play the video for a bit. And you can see immediately that it starts to get a coloration change inside the beaker. And let me kind of move it up a little bit faster. So we'll look all the way out here. And let me play it there. So this is like 10 minutes later. And so now, 10 minutes later, when you pull it out, we got the same dialysis bag. It seems like the color has changed a little bit. If we were to now test it for glucose, what we would find is that there is still going to be a positive for glucose inside. But now if we look out here, there's going to be a positive for glucose out there with a test strip. And so that's kind of all the diffusion demonstration is. So now your goal is to figure out from smallest to largest, can you rank these 5 things? And you're going to have to use an understanding of diffusion, but you're also going to have to use logic to figure that out. And I'm not going to tell you the answer. So I hope that's somewhat helpful.